All right, question 54. This is about a plane flying at a given altitude of 11,500 meters high, and that plane spots a stationary ship in the distance. That means the ship is not moving. That is in the same vertical plane as the jet's course. That means you can use the surface of your paper to draw it, right? The plane flies in the same the plane as the boat. The path of the plane and the boat are in the same vertical plane. Okay. The pilot measures the ship's angle of depression and find that it is 16 degrees. 2 minutes later, with the ship still ahead of the plane, the pilots find that the angle of depression is 46 degrees. And we have to find the speed of the jets. Okay, all right, so let's see what's going on here. I'm going to put my ocean right here. Okay, the boats will be here. Here's the vertical path, the horizontal path that the plane, this is not very straight, parallel to the ocean, of course. Alright, and here's the first position of the plane, right here. And here is the second position of the plane, right here. Okay, so this is a distance that the plane flew in within 2 minutes. So it's not really a distance right now, we just know the time, and this is just 2 minutes, right? What else do we know? We know the altitude that the plane flies in, and this altitude doesn't change, and it is 11,500 meters. And we know the angles of depression. Don't make a mistake on that. Angles of depression are measured with a horizontal, okay? So this one is 16 degrees, and well, this one is 46 degrees. So drawing an accurate picture of what's going on is really essential in this problem, okay? Okay, all right. So how are we to find the speed of the plane? I know that the plane flew over that distance within 2 minutes, right? So if I can get that distance, if I know what that distance is, let's call that x. Okay, if I know x, then I have a distance, I have a time, I can get the speed, right? So how are we going to get x? Well, look at this. X does not belong to any right triangle, right? And we're only doing right triangle trigonometry, so there's an issue right there. Next year you will see how to deal with that. You can do other kind of trigonometry that is not in a right triangle, but right now for us it's just right triangle trig, okay? So what do? Well, I see a right triangle right here, and actually I see two right triangles. So I'm going to try to find x by looking at the big right triangle right here, right? So I have this is the opposite side of x, and then I need to consider this one, the adjacent side. Therefore, I also need to name this length right here. So let's call that y. All right. So after that, we've seen this kind of problem before, right? Let's start by writing some trig formula. And of course, when you deal with the opposite and the adjacent, you're dealing with the tangent function. So tangent of 46 is right here, is the opposite over the adjacent. So it is 11,500 divided by y. Well, that's very easy to solve for y. So that implies that y is 11,500 divided by tangent 46. You do not need to take your calculator to find that, right? I mean, this is not what we want in this question. So I'm just gonna leave it like that. Okay, let's have a formula that deals with x. So again, we need to look at the tangent of 16 right here. Tangent function. So tangent of 16 degree. Well, it's the opposite, which is still 11,500, but now divided by x plus y. So 11,500 divided by x plus y, and we're going to do the same thing. We're going to solve this equation for x plus y, and we find that it is 11,500 divided by 10 of 16, right? So now it's pretty simple. Let's solve this equation for x. Therefore, x is 11,500 divided by 10 of 16 minus y, which is just 11,500 divided by the tangent of 16 degree minus, and y is right here, 11,500 divided by the tangent of 46 degree. Alright, now this I do need, right? So let's figure out how much that is. I'll take my calculator. Okay, let's clear everything. 11,500. So actually, I'm going to factor that because I mean, you can factor it, right? Times 1 divided by the tangent of the first one is 16. Minus 1 divided by the tangent of the second one is 46, close, and that is, okay, so it is 28,199.8. So it is 28,999.8 watt meters. Alright, well, listen, this is what the plane covers in 2 minutes. So now let's get the speed, right? That's going to be pretty simple. It's just a change speed. So let's get the speed. This is covered in 2 meters, right? So if you look at this number, 28,999.8, and if you divide it by 2, what are you getting here? You're getting what the plane covers in 1 meter. So this is in 1 minute, sorry. So this is meters per minute, right? If it covers that in 2 minutes, then it's going to cover this distance in meters per minute. So what do we need to do right here? Well, we want kilometers, so you have to divide by 1,000, right? So I'm going to take this number right here, which is easy. I'm going to move that decimal point right there. Okay, I'm going to take this number, and I need to divide this by 1,000, and that's going to be kilometers per minute, but then this is in 1 minute, so in an hour it's going to be 60 minutes, so you multiply by 60. So you multiply by 60 over 1,000, right? And this is just what? So it is okay, let's simplify. Okay, so 3 over 100, so this is it, it's 20. You don't have to do all of that, just take your calculator, okay? Times 0.8 times 0.03. Okay, so let's do that. I'm gonna look at this number, so I'm gonna time that by 0.03, right? And I find 800, and well, if you round it, that's 870 kilometers per hour. Oh, right. Actually, I should really put the units there. This is kilometers per hour. So it is the number that I started with times 0.03 kilometers per hour, and we just saw that it was, oops, not 270 but 870 kilometers per hour. Okay, so we got the distance. I'm sorry, we get the speed, about 870 kilometers per hour. All right, the second question, well, it's going to be right here. If the pilot does not change its course, how long will it take the plane to be directly on top of the ship? So we want to know, this time we want to know how long it's going to take the plane to get here. So we want to know the time. Okay, for the second question right here, we want to know the time, because you can see that right there the plane is going to be directly over. So A, we know the speed, we know y, right? I mean, we haven't looked at y, but it's right here, right? It's right here. So it's easy to get the time. You don't remember the formula? Well, think of the units. What do you have? Like the speed. Speed is what? It's a distance divided by a time, right? Distance divided by time. Meters per hour, or miles per minute, whatever. Therefore, so a time is going to be a distance divided by a speed. Now you're going to have to be careful that the units correspond, okay? If you're taking the speed 870 kilometers per hour, you can't use a distance that's going to be in meters, okay? It has to be in the same unit of distance, okay? Okay, so so let's go over the formula. So the time here is going to be y divided by, now what am I going to use for the speed? I kind of like this one right here, meters per minute, because this one right here, meters per minute, because I'm pretty sure it's not gonna take more than an hour, right? I believe it's gonna be pretty fast. The plane flies very, very fast. So I'm gonna use this speed, okay? And for the distance, well, I know what it is. So I'm gonna use that speed. So I'm gonna say divided by 28,999.8 divided by 2 right here. Okay, so what is that? All right, let's get the y. Y is 11,000 divided by 1046. So here we go. So I got y, 11,500 divided by the 10 of 46. Okay, and times, so I'm gonna flip my fraction, 2 over 28,999.8. okay. Okay, so the time, and that's gonna be careful, okay, we know that's in meter, okay, the distance is in meter, and this is in meters per, I mean, well, it's flipped, okay, but this one right here is in meters per minute, okay, that's minute per meter. If you flip it, you find it kind of makes sense if you look at the, okay, here let me use International System of Units symbol. So if you multiply meters by minutes per meter, you're gonna find minutes, right? Okay, so let's do that. 11,500 divided by the 10 of 46, right? And then times I guess I'm gonna put 2 divided by and this is the number that is right here, okay, so 28,999.8. okay, let's close it, and we have, okay, so it's actually less than a minute, right? So the answer that we find is 0.7659, so I'm gonna turn that, so 0.766 minutes. Of course I don't like that very much because it's a fraction of a minute, so let's multiply by 60 to find the second, and it's about 46 seconds, okay? So in about 46 seconds the plane will be on top of the boat. Alright, so the trigonometry in this problem was not too difficult. We had seen things like that. What you have to be careful in this problem is working with units, okay? You need to be able to switch units. Alright, let's move on and find speed and stuff like that. Okay, here's a most straightforward problem. The cosecant is -3, so you know that, and let me write that down. The cosecant of the angle alpha is -3. That means -3/1. Now you know that cosecant is r over y, and r is never negative, so this is 3/-1. Okay, so what you have right here is that r equals to 3, y is -1, and x is plus or minus, and we're going to have to decide r squared minus y squared, so 9 minus -1 squared, which is 1. So x is plus or minus square root of 8, which is plus or minus, always simplify your fraction, okay, 2√2. Okay, is it a plus or a minus? Well, let's see. Cotan is negative now. Cotan is x over y, and it's negative. Y is negative, therefore x has to be positive. So x is 2√2. Okay, we got a y, we got the r, we got a y, we got the x. We can get any other trig function. I'll start with the sign, and I'll just flip that, -1/3. Let's go with cosine of alpha. It's x over r, so 2√2/3. And then the tan of alpha, which is y over x, so -1/2√2. Okay, yeah, -1/2√2. So then let's get also the secant of alpha, which is 3/2√2, and then the cotan of alpha, which is just -2√2. Okay, when it's over 1, I don't write it. Okay, that's it. 56. Okay, so I'll stop this video right here, and I think I may just finish the whole correction on one more video. Okay, here we go.